Hello, everyone. Good morning, good evening, good afternoon, depending on where you are located. I am so glad that you're joining us today. My name is Amy, and I am the Webinar Programs Manager here at ApplyBoard. So thank you again for joining us for our Careers of Tomorrow workshop. I am very pleased to be joined by the University of Strathclyde today for our session. But before we kick into that, I don't want to keep you from the fantastic information you're going to hear. I just want to give you some housekeeping remarks before we get started. So we are live on YouTube and Facebook. So thank you again for joining us today. If you have any questions for our speakers throughout the presentation, please type them into the chat box and we will be answering them at the end of the session. So as you think of them, put them in the chat box and we will get to them at the end. We are live for about an hour today, so that question and answer period will come at the end of the session in about 45 minutes. And our Careers of Tomorrow workshop, it's a really exciting program that we are bringing to you all about in-demand careers. So we're talking with faculty members really to help you learn more about what's hot, what's coming up in the future, and what those career opportunities look like. So without further ado, it is my absolute pleasure to welcome Robert and Dr. Yang from the University of Strathclyde. Hello, gentlemen.
Hi there.
Hello.
Hi, it's great to have you. Robert, I'm going to pop up your presentation for you, and I will pass it over to you to give your introductions and take it from there.
Excellent. Thank you so much, Amy. Okay, I hope everyone can see that. So, as Amy said, my name is Robert Graham, and I'm from the Faculty of Engineering at the University of Strathclyde in Glasgow, Scotland, which of course is in the north of the UK. And today I'm delighted to again formally introduce my colleague, Dr. Erfu Yang, who's a senior lecturer from the Department of Design, Manufacturing and Engineering Management within the Faculty of Engineering at Strathclyde. And Dr. Yang's session today will be the live workshop specifically focusing on mechatronics and robotics. So before I hand over to my colleague, I wanted to just give you a very brief overview just to set the context in terms of my university and their faculty as well. So we are, as we've said already, from the University of Strathclyde. So the university itself has got many, many years of tradition and history dating back to 1796. And we were very much built on this ethos of useful learning. And how that translates as we've gone on throughout the years is that it means that our students are gaining really high-level experience in terms of the work with industry, and it's making them very career ready for when they graduate and then go into the huge world of work. Okay, and that is where our term useful learning has evolved over the years, particularly, may I say, within the Faculty of Engineering and within the Department of Design, Manufacturing and Engineering Management. Okay, so we've grown as a university to become one of the largest universities in Scotland and the rest of the UK as well, and renowned throughout Europe. And that is has been indicated by many awards that we've been awarded at a university level. So we've grown to have approximately 22,000 students. Okay, so I'm sure a lot of you are aware of where we are. I'm thinking that my accent itself might give some of that away. So we are based in the city of Glasgow, which is the largest city in Scotland and one of the largest cities in the rest of the UK. Okay, so if you just look at my image there of the UK, which I'm sure you're familiar with, we are up in the north of the UK, of course, within Scotland, and about an hour's flight from London. Okay, so obviously the last 18 months has been an interesting time for everyone. And on a cautiously positive note, we are seeing a bit more movement now in Glasgow and Scotland as our vaccination programme is really kicking off. And with that, it's meaning that potential students like yourself or people that are telling students to come to Glasgow and Scotland, it means that we're going to get back to some sort of normality. And that means that you're going to enjoy the friendly environment, the passion and the friendly welcome that we always aim to make sure our students get when they come to Glasgow and to Strathclyde. Okay, so as a country, obviously we are slightly smaller than many other countries with a population of just over 5 million. But with that, there are a lot of advantages, because within Glasgow, you're always close to the city centre, of course, but you're never too far away from the beautiful scenery that Scotland has to offer as well. And within the city of Glasgow, very famous for events and cultural events as well, in particular for music events as well, and for shopping too. So lots to get on with in terms of experiencing in your time in Glasgow. And again, as we come out of this situation of being in, we're looking forward to welcoming more and more students to our wonderful city and our wonderful country as well. Okay, so very briefly, I'm just going to give you an overview of engineering at Strathclyde. We, as a faculty of engineering, are one of the strongest and one of the largest within Scotland and the rest of Europe. Okay, and that is very much indicated in the wide range of programmes that we offer, both at an undergraduate level and a postgraduate level as well, and also with the major research work that we do, which my colleague Dr. Yang will go into in more detail from his department. Okay, so within the faculty we have the 8 different departments, and today's focus will be on the design, manufacturing and engineering management. Okay, so that's all from me. I'm going to hand over now to my colleague Dr. Erfu Yang, who's going to speak more about the main topic of today's session. Okay.
Thank you, Robert, and hello, good afternoon, everyone. As Robert said, I'm a senior lecturer at the Department of Design, Manufacturing and Engineering Management. So hopefully you have a better understand where we are at University of Strathclyde. As Robert mentioned, we have 8 engineering departments. So I'm in the Dmem. In the Dmem, we have the group called the Robotics and Autonomous System Group. So that is today. I'm going to introduce our group and the project we are doing, and what kind of opportunity as a student for either a postgraduate or PhD level. So what opportunity we can offer for you to study. So as the department, Dmem, so you see we cover the very different research topics from the design, engineering design, is a big block, and then is advanced manufacturing. So finally, engineer management. So this is the unique department across UK to cover from the end to the end. So that means from design, manufacturing until the management. So that is only unique department in the UK and also in Scotland. So we, from the research folks, you see, we have the design and the manufacturing is for sustainable development, and then general technology system, materials processing. Of course, we have the creativity and innovation as well as operation studies. So in the department, we have around this very diverse research groups. So first is like design manufacturing, digital manufacturing, advanced manufacturing research center. That is big center, is just very close to the Glasgow airport. It's part of the department. And myself, and we are based in the robotics and autonomous sales groups that I highlight here. So today we are going to give you more detail about this group. Of course, we have the space mechatronics system net to support the group work. Some group include like engineering management, Strathclyde Operation Institute, Center for Precision Manufacturing, as well as Sustainability and Remanufacturing groups. So, a lot of the groups we cannot go over all this. So as one of the important group is RAS is in the core of the department, has been involved a lot of research. So for that reason, so in my talk, so the first I would spend around 50 minutes to introduce what is the RAS group, what we are doing, and then we can go over some recent robotics research projects in the group we are doing. Again, so we have a lot of robotics related projects within the half hour. I cannot introduce all of the projects, but from the high level in the introduction for this project, I hopefully give you some information what kind of research we are doing in the robotics and the mechatronic domain. So as a student, you might be interested in what kind of mechatronic robotics course we are offer, what kind of industry engagement as the department during your study we could offer to allow you to work with the industry. Also, what other opportunities we would be offered to you. And then we highlight some major points from my talk. So let's say what our RAS group. So RAS group is the purpose is to advance the mechatronics, automation, robotics, autonomous system related research and technology, as well as provide research knowledge expert in 8 areas. So the first is how the system development, what kind of methodology can be used to design, develop the robotics system, how to model, how to simulate, what kind of tools we can use. For example, in the group, we have developed a modular design tools for reuse, remanufacturing. Of course, is in the mechatronics and the robotics domain. And also we investigation of mobility. Here is from the my slide. You can see we have the agriculture rover. So that we developed the agriculture platform is a robot to help to modelize the agriculture production. Also for other applications like wall climbing robot, UAV, drone related things, I would be give you some projects how we use UAV to do the inspection in the oil and gas domain. And the third area is to investigate the sensing and the payload. For example, in the agriculture domain, how using agriculture robot to sample soil and to provide the sensing for the robot to move around a very complex agriculture field. So that is linked to the environmental awareness perception through the data fusion. For nowadays, many robotics have been used for different areas, especially to provide autonomy. So that is from a group we did research, multi-sensor based manufacturing of cakes or remanufacturing components, these kind of things. Also the autonomous navigation in the challenging environment. So again, so we have around 10 staff members, a lot of the PhD postdoc researchers as well. So the group leader is Professor Yan, and I'm one of the member of staff in the group. So the for the other areas like the group we are doing like automatic actuations. So that is can be used for manufacturing of the food, all the different components. Also, for some area like Dr. Butler, who is a reader, joined us 4 years ago from NTU, is expert in the surface measurement using the robot, for example, to do the polishing, how to control the force, how to do like consumable benchmarking and validation for different components. For some medical applications using the robot, for example, we using the haptic or surgical tools, the robotic tools, to planning and training the young doctors, dentists to do the surgeries. So that is linked to the healthcare applications. Widely for the manufacturing, using a robot to inspect the components. Like you have see from my slides, the robot can be used for flexible robot integrated inspections, in-process monitoring, automation for very hazardous environment, like in the nuclear materials processing and other things. So that is for the group, we have done a lot of the research. Of course, we have a lab to support our research. You see, from here, we have the industry stability robots, from the 6UF arm robot to the SCAR robot, and also we have the mobile robot, some latest human collective robots called Cobot. This universal robot here, and some others range from the drones to the robotic related sensing devices. So here we have 3D cameras, we have a haptic device, we have other sensor and control components, controllers, always used to support our robotics automation related research and teaching. So you say the in summary, so our RAS group is focused on the system design. So that is major for methodologies. Then we have navigation, sensing, autonomy, control, human robots interaction. So that is from research, we focus all areas. All the area linked to the very important applications, because Strathclyde, we have vision to develop a useful learning and research. So the application majorly in the manufacturing. Then we have applications in the oil, gas, and the energy domain. So for some application linked to the space-related applications, other application in the healthcare, of course, we have like other like transport-related domain. So whatever we do, we try to address the industry needs and challenge, ranging from manufacturing, energy, even space like deep sea, or some healthcare, so wide. So that is to say, every day, if you are interested in the robotic research, in the Dmem, we offer freedom, we offer opportunity, allow you to conduct relevant research. So this is the very quick overview, the RAS group and what kind of the research we're doing. So then I highlight some of you research projects I have been involved over the last 5 years to give you further idea what the project look like, what kind of application issues we are trying to address. So the first link to the, because we are in the design manufacturing department, so our research focus on robotic manufacturing is trying to answer the question, how industry robots can adopt to industry 4 age, because the industry 4 is current technology driver for the future. So in robotics related area. So what are the challenges we can solve? And especially how AI, artificial intelligence, together with the robotics can help to address these challenges. So that is say, through the robotics and AI and other science technology, we would provide some new features for the robotic system, like flexible, intelligent, adaptive, dynamic, and also interactive way for robot to solve the manufacturing related issues. So the first project I'd like to say here quickly is EPSRC funded research project. Is called Smart and Flexible Automation System for High Value cake manufacturing. Right. So that this project involved 3 partners. From the slides, you can see University of Strathclyde is the research organization we have contributed to the project. We have the end users, is a company who manufactures the celebration cakes, and other industry is SME Stereo. All 3 partners work together to deliver the robotic solution to the cake manufacturing. Say in the UK, when you go to the supermarket, you see a lot of different very lovely cakes. So in its manufacturing, so the project was to develop a robot solution, how to use the robot to help to improve the automation, also improve the productivity, as well as profit for the company. So that is the project for. So the system involved the industry robots, also the camera system in 2D, 3D, and some control industry control system. Here we use the back-off and other Ethernet industry communication ways to successfully deliver projects in the labs. We have the exact same robotic system after project to continue supporting the research and teaching in this area. So the second project is using using the industrial robots and other like digital training techniques, from the simulation to control, path planning, and include like sensing, machine vision, all is in the integrated ways to address how using the make the industry robots smarter by adding the different robotics, mechatronics related components. So if you are interested, you can see our publications and from this journal. So we call it Smart Sensing and Adaptive Reasoning for Enable Industry Robots with Interacting Human Robots in Dynamic Environment. So that is the project we done. And especially to support that project, we developed a new approach. As you see, we have very, the human can use in the hand to, from your mouse, the laptop, to control the robot arm with low latency and adaptive behavior. So that is the key to deliver how the robots have like very, the smart behavior capability to respond if something happening in its working environment. And then we tested all this, our research from the algorithm, sensing. Here you can see we work together with the FRC using the large industry KUKA robot to get this robot have the sensing capability. Also, when it's working, is something another moving object coming into its working scope, so they can respond to avoid obstacle at the same time to find the path for the robot to do the work. So that is the project. Another project is we developed the robotic solution how to do the fast and unified task and path planning in very challenging environment, because nowadays the robot is not only sitting in the factory, it's in the structured environment. In many cases, it can be very the complex scenario. Like here, if you want to use the robot to do inspect of the large aircraft wings or engine components, all the things the robot can be on the mobile platform. Even like if you using the robot to inspect like oil gas pipes, all these tasks require the industrial robot has very clever decision making and path planning capabilities. For that reasons, we have conducted research how make the robots like this scenario. The robots want to inspect the pipes. These pipes in the robot work fire, it's very close, very crowded, right? So how to get the robot to inspect the surface as quick as possible, but at the same time not locking down the components, it's working. So that is, we have recent publications in the Mechatronics IEEE transaction Mechatronics to fully document. You can download to read the details. That is one of my PhD and myself. We have recently to develop this robotics inspection with clever path planning capabilities. The fourth project I'd like to highlight we have doing to address the challenge for the composite manufacturing domain. So in the composite manufacturing is the area, the automation degree is quite low, involve a lot of the human labors. So, but this components is high value, use the marine time, using aerospace, using a lot of even sports engineer. So, but the manufacturing of components is very hazardous for human, because it's, as you say, people need to wear the mask. Some components, some reason has posed the safety risk to the workers. So the solution using the robot to how to deliver intelligent and correct robotic system to help human to avoid a safe environment, and also make sure the quality of the component manufacturing as required. So that is we using the modern tools in both simulation, like software we use in robots, and hardware. A lot of the robotic related hardware, as we listed in these slides. Of course, as the robot, we cover from like hardware programming, also the sensing hardware equipment. So that is to study. Probably you need like programming skills. At the same time, you have other mechanical related knowledges. For these things, you say like simulations, we demo how we do like integrated pick place from one small robot to pick up the very soft copsing materials. Say in this called digital twinning like environment. So actually, this kind of simulation has been play a big role during last the challenging COVID-related lockdown scenarios to allow the research and also our teaching have the good qualities, give the students a lot of the modern tools. Without access the hardware, still we can guarantee the teaching, learning, and can be done in the very satisfactory ways. So that is this video show how the simulation, robotic-related simulation, to deliver integrated the solution. Other things like I mentioned in our group, myself, we have developed like UAV, because UAV drones are quite popular, has been used a lot of areas in the industry. Our research is showing the drone UAV can be used for the visual inspection for very important industry equipment component, like here I show. So this is the oil gas pressure vessel, widely used in industry. So traditionally, this is a very challenge, because over time, so company industry need to set human. As you see, this picture, you need to spend a lot of time to prepare for the engineer and then deploy the human into a very confined, dangerous environment. This is cost a lot. Also, it's not safe for human. So the solution for us is to develop robotics, especially using the drones, UAV, to do the research. Of course, this research has a lot of the challenge, because inside the vessel, there's no way to using GPS to give the UAV no location required. So that is we developed the solution how you use the UAV to localize these drones in very confined, like in our labs. We test the drones to develop the UWB-based localized solutions. As you see, we do this kind of research, and also we not only one drones, we also developed swarm UAVs to make the work more efficiently, especially for a large vessel. How to do this? So how the two UAVs as a swarm to collaborate. Like here is the experiment we have done. So the two drones, one is just for communication, lighting. Another drone is fly around, take images for corrosion detection, these kind of things, right? So this is the UAV related research we are doing. Of course, now we are in a lockdown environment. We still we cannot do the pressure vessel outside the university, but we still do using the digital twinning simulation to say this is the fully developed the vessel CAD model, and then integrate the related mechatronic and the robotics component to simulate how the swarm of the drones to do the work in this scenario. So that is in terms of research. So I quickly outline our some random research for the PGT and PhD opportunities. So the DMEM as a department, we offer a lot of MSA courses might be suitable for you. I highlight 2 courses. One is called Mechatronics and Automation MSA. This course is purely run by DM, and also as university, we have joint effort to deliver robotics courses. This is the second, called Autonomous Robotic Intelligence System, MSA joined with the EEE department. So that is particularly in the course title, we have mechatronics, we have robotics. Actually, in the DM, a lot of other courses in the title doesn't necessarily have robotics, but in the context, a lot of opportunity to using the robotics and mechatronics. For example, advanced manufacturing, digital manufacturing, system engineer. All these courses might be have a kind of interest to yourself. So I put the contact email here. Any questions after this presentation, you can send an email to this, or if you want to know about more course contact and its requirements. So that for other opportunities in the DMEM, we have the research program. So that is includes the different research degrees from MRES, MPhil, and PhD. So in the slide, you can see the different time scale from 12 months and for PhD is 3 years minimum for the study. In the DME, also offer the engineering doctor in advanced manufacturing. So that is a large opportunity, allow you to using your robotics, mechatronic knowledge for forging, forming. If you working for some company, but same time you want to have a doctorate degree. So that is a good way for you to explore. Of course, like Robert probably give you more opportunity for what kind of postgraduate related studentship from the different level. Especially we offer the PhD scholarship every year. Some is based the research proposal excellent from staff. Some is based you how excellent your performance, and the opportunity allow you to do the research degree in the DMEM. Okay, so some example in my class linked to different levels. One is, for example, here during your studies, we offer you not only just sitting in lectures, do some online work. Like before lockdown, we have the robotic related hardware, sensor. Also, we have in the class, we do like competition related project based learning. So that is the year, the class before lockdown. So you see the students end of the course develop a mobile robot solution to compete each other and to as a team to learn the advanced mechatronic and robotics content, and for other related like using small robot, like using LabVIEW to programming, allow you to build your own robot to run the code. So this is a different module we offered for you to learn the robotics and mechatronic content. Most importantly, during your study, as university, myself and other colleagues have been running a robotics education course. So this course has been running for at least 10 years. So that this is we call the VIP, means vertical integrated project. So the students can come from different department, different the subject, and of course different years, to as a team work together to design, build, develop a completely autonomous robot vehicles for different applications. So some years the robot developed, for example, to investigate the how to inspect the wind turbines. So that is say in the team 2016, 17, 18. So every year the team change is quite international, quite multidisciplinary. And of course, in the Dmem, we are hosting these things. I also have a link here. You can find more information about our VIP, rover VIP project. So for the year 2021-22, I'm the project leader. So what we are going to do is to develop autonomous shopping robots. So that is the solution we are consider as a student together, how as we can contribute to fighting against the COVID pandemic or post COVID pandemic in the shopping scenario. So that is we have run this project for 2 years. We have been very successful in before lockdown. The rover project, we have the team, you see, developed the whole solution to rover in the shopping market. And so the good result was the team has won the international reward. So that is a very, so the students for this is say from a mixture from UG to PG, right? So it's in the degree program range from some maybe from product design, some from robotics, automation, some from the factory engineer. Also, we have factory science. So all the program provide a unique opportunity for you to develop your interests, skills, knowledge in robotic and automation domain. Of course, Dmem has a unique program we call the industry group project. So the industry, this is allow you to have a wide industry engagement during your study. So every year we involve our 4th year and 5th year undergraduates and also postgraduate PGT course students in industry projects. So please watch these YouTube videos to have better understanding, better ideas. What is our industry group project? What's the benefit to you? Just before watch video, so this is one of my industry group projects. We're working with the global leading company called Unilever, right? So MSc student, you see from photos, during just the last January before lockdown. So we visited the company in the Europe. So we have developed a really positive, continual opportunities for you to engage when you join us to develop the robotic solution for company through your study with us. Okay, so I play this YouTube video now.
Yes, Industrial Group Projects is one of the flagship events within Dmem. One of the mottos of the University of Strathclyde is to be a place for useful learning. And one of the ways in which Dmem ensures that the student learning is useful is through Industrial Group Projects. So every year we collaborate with around 50 different organizations. So when students sign up for Industrial Group Projects, what happens is they get assigned to a company and they are mentored by a representative of the company and are also supported with academic supervision. We are developing a project that's going to be implemented in our real world, in a real industry.
So basically, it's just like a trial for the next step when we are going to work for a company. So I think it's quite useful.
So the project was with Unilever and more specifically with Podnodo. And the aim of the project was to implement a solution to automatize one of the stages of the production line, which was to put the pots inside the production line. So it was in order to reduce the repetitive tasks of the operator. Some groups worked with startups and some other with really big companies. So you have very broad, very wide range of possibilities of companies to work with, and it's of course gives us more skills for the future.
We are part of the Dmem industrial projects. This is a project that we actually sponsor. So we are gold sponsors for the event. So we do surgeries with the students, and we get a bit of a feel for the projects, give a tiny bit of advice.
Okay, thank you for the watching that video, and that is the industry group project. In addition to that, former study mode, we also provide the other opportunity. For example, here I show in the robotics UAV related UK challenge, so organized by BAE System. So as the student, you have opportunity to attend to join this kind of teams. Of course, there are some sports related like race car, but the UAV sports, BAE sponsored UAV small challenge was running every year before lockdown. Unfortunately, during lockdown, it's some limitation. We can't do that. But this is the year before lockdown. So we, as the Strathclyde student team, of course, I'm the academic leader. So we won for you prize. So the competition is the university from Birmingham, from Manchester, from Crawford University, all the UK university. The students, you have a chance to meet, to compete, and you see that is the UAV related activities. Of course, that is not to give you credit, but give you opportunity to engage with other universities, industry, to develop your skills further outside your course structure, right? So as department in the robotics is a very important area. So we have been continually investigating to the equipment. For example, just during lockdown, we have purchased the state-of-art, the collaborative robots called cobots. This allows us to develop the human robot-related solutions. You can see how it's operation. When you join us, you will have opportunity to work with this cobot to develop your human robot related project. Okay, so thank you. Watch the videos. This show how the new cobot equipment available and be ready for you to use it when you join us for either PGT or PhD study with us. So I move to last slides. So just a quick summary. As the DMEM, we focus on research excellence, effective industry partnership, and creative engineering education in mechatronics, robotics, and autonomous system. So our research is centered on the vision to deliver total engineering, that is from design, manufacturing to engineering management in our research area. So we have a number of world-class research centers groups across department to give you excellent learning and research experience. Through the PGT, PGR opportunities, we look forward to welcome you to join us in the new academic year. So finally, I'd like to use a Chinese very famous poem to says, if you want to see far, far away, if you want to see far, far away, you must continue to climb to a higher mountain. So that is the famous poem, Li Bei. All right, so Chinese Robert Burns, something like that. So finally, I'd like to thank all the industry and online support to our research and teaching. I can't put on the complete organization, but here you can see the big names from the KUKA, Unilever, BAE System, Rolls-Royce. Always is part of our research, partner also for other funding organizations through the UK, also the EU related research. All right, so thank you. That is my short introduction to the robotics and mechatronics in the DMEM at the University of Strathclyde. Thank you.
Oh, that's great. Thank you so much, Dr. Yang. Really appreciate you sharing all of that information with us today. I saw some really cool projects that your group is working on. You showed the cake automation, which was fun, and then that last video with the building blocks too. That was really great. So thank you for sharing that information with us today. We have some great questions coming through on our different channels, so we'll jump right into them. We have a little under 7 minutes left to go, so we should be able to get through a few questions, and if anyone else has some, please do share them in that chat box so that Dr. Yang can answer them before we sign off today. So I'm going to start with a question about the degree itself. And this is coming from Liam on YouTube. And Liam's asking if a mechatronics degree is mostly hands-on work, such as programming, wiring, etc., or if there's more theory and paperwork.
Thank you for that question. That's a really good question. Actually, as a mechatronic robotics is actually cover from programming, also mechanical parts. So that is why we call it mechatronics. It's kind of the mixture. You have to develop very comprehensive skills and knowledge. So that is, of course, some project depend per lecture. You can more focus on programming aspect. Also, some project you can be more focused on mechanical design aspect. But it's kind of the hybrid manner.
Perfect. Thank you for sharing that. And I know you had a lot of different programs that you showed as well, and really hands-on classes. So we know there's a lot of those projects as well that students can work on, which is great. You had the swarm challenges and the various campaigns. So that's definitely something students would look forward to if they were interested in joining the Faculty of Engineering at the University of Strathclyde. So that's great. We have another question coming through from Sakshi on Facebook. And this is another great question for you, Dr. Yang, and Robert, feel free to jump in if you have some thoughts as well.
Yeah.
But the question is, what do you think, in your opinions, is the future of robotics? And then what will the next 20 years look like?
Yeah, that is actually in terms of academic thinking. In the we definitely think the robots in the future is much closer to human, because traditional robots might be sitting in the factory, but the robots is come to the human life. Is especially in the healthcare, how use the robots to address the to look after the older people, or even provide useful services. So that is to say, it overlaps the robot and the human is become a more unified society to provide the benefits, values. Of course, a lot of the research also not only for the technology, is about the how to people accept the robots, how to share the same, like you have the robot in your home, how you trust them, how to build partnership. So that is my the vision for next 20 years. You will have a great opportunity to see a lot of robots come to your daily life.
Perfect. That's awesome. And I guess that question kind of takes me to one that I had personally, and that's regarding the ethics. So what are your thoughts about ethics and bringing robots more and more into the home? We even talk about digital devices like Alexas and the concerns with those. And now if we're talking about bringing these autonomous systems into our homes that can help us with daily life, what might be some of the ethical issues or not ethical issues that we kind of need to break the barriers on to be more comfortable with those?
So that is in terms is a large area called social robotics. So that is in terms like ethics or some acceptance, safety, trust. Even when you look at the autonomous drive cars, is a big issues. But for the robots come to your home, come to the community, is something takes a long time, and that is why, as academic, as researchers, we are working to address all these issues step by step. Of course, like European Union has already set up some kind of a protocol ethics, something like AI robots is to be meet the requirement human. So that is actually is really good if you want to do this kind of PhD research. I'm sure that is a really timely and relevant project. At Strathclyde, we welcome the students. You propose your own project. We give you a lot of the freedom, flexibility. You can propose your research. Say, I want to develop some project. Actually, it's a good example. I have a student who developed a drone, how to using gesture, using their face to make their body more active, for the sports. This kind of is self-purpose project for because for your PGT you have a industry group project. Also, you have individual project. So that is. You have opportunity to self-propose this kind of interesting project. Of course, as department at university, we encourage, we support, we provide the equipment, staff, knowledge. We have a dedicated staff team to allow you to realize, to test your, so wonderful robotic related ideas. So hopefully I answer your questions. If not, I do welcome follow up, through email. I think I'm sure Amy will share our contact details, and we look forward to further, discussion through the emails or other ways. Yeah.
Wonderful. Thank you so much for that answer. And to echo your comments there, Dr. Yang, absolutely. If you are looking specifically from an ApplyBoard perspective for application details, more details about the programs and the universities that we feature in our sessions, then please do check out our ApplyBoard platform. All of the details are there. You can learn about what the requirements are by checking that out. So Dr. Yang, Robert, thank you so much for joining us today. We are at time, so this has been a great session. Everyone joining us live on Facebook and YouTube, and anybody who watches this session on replay, thank you for joining us. Thank you for being here. Thanks for staying engaged. We really appreciate it. This is a series, so this is our Careers of Tomorrow workshop. We are continuing throughout the rest of the month of June, so please hit that subscribe button and hit that follow button so that you are notified when we go live again for future sessions. We also have our social live sessions taking place on Fridays, so don't miss those. And we look forward to seeing you back here next week for another Careers of Tomorrow workshop. We'll be featuring the University of Central Missouri, and they will be providing a deep dive on AI and deep learning. So thank you again so much, everyone, and we'll see you next week.
Thank you.
Thank you.
Bye.
Bye.